After the success of my first touch remote control, which was dedicated to the DBX4BX audio expander, which required only 11 buttons, though I've added a 12th for macros, I decided I should design a 28 button remote which can be more universally applied to various different domestic equipment, customised with the codes and of course with the overlay, which can also be customised for specific different pieces of equipment or even multiple pieces of equipment. This one, for example, I'm proposing to operate both my PVR and my TB. As well as customising the code, I can also customise the overlay. This is only a paper dummy, but for the final, of course, they'll be printed like this one is on polypropylene and with a clear polypropylene overlay which protects the printing. So what then needs to be done is connect the various boards. Now the 4BX remote had just a single board because there was enough space between the buttons on the rear of the board to fit the microprocessor, etc. I just needed a single board. But with this one, because there are 28 touchpads, there's not enough room on the back to fit the microprocessor and all the peripheral components that go with that. So I've had to create a second board, the rear board, which has the microprocessor and a whole lot of supporting components. And these will be connected by a surface mount pin header. So it has surface mount pins, bent pins on one side and the straight pins on the top. That goes here on these pads like so, more or less, and the microprocessor board then will connect via these holes into those pins. So the front board with the touchpads sits hard against the inside of the front so that it responds to touches of the finger. It's going to be easier to show this way. And the rear board with the microprocessor is screwed onto these posts and eventually connects via the pin header, which is soldered to the front board and eventually will be soldered here to the rear board. Because the rear board is going to be screwed into these posts and therefore fixed in position, and the front board is also fixed in position by virtue of its shape and how it fits into the front, it's important that the pin header, this, is soldered accurately on the front board so that when I solder it to the rear board there is no stress between the two boards and the connector, which would ultimately cause failure of the solder connections. You can see from the gap here there's no way I can get my soldering iron in to solder the bottom of this pin header onto the front board. So what I've come up with is a jig which I've made from an old reject rear board by cutting the end off it, as you can see. So the connector is right at the edge, and I can then put that in place and I can get access to the pins on the pads of the front board to solder. I can tack down 2 end pins, for example, and that then allows me to remove this jig and finish soldering the connector onto the front board. It's important, of course, that the alignment of the rear board is correct when doing that, otherwise it could be soldered in the wrong position. And to achieve that, I've asked my 90-year-old brother, g'day Peter, who has an excellent workshop and is very skilled in machining, to make me 2 of these locating pins from brass. So they're a stepped pin. The narrow part goes into the holes of the posts and the wider part goes through the hole in the circuit board. So by inserting those into two diagonal corners, like so, the board is securely located in its final position where it will eventually be screwed down. I can then tack the two pins of the connector to the front board, remove the jig, finish soldering the connector onto the front board, and thereafter, once I assemble all the components onto the actual rear board, it can be just screwed in place and will exactly align with the pins of the connector and can then be soldered.